This is a demonstration video of how to use RCIF-2D. Once you start the app, you're welcomed by this screen where you can load or create a new model. Um, if you decide to create a new model, which is the example we are going to demonstrate here, you go directly to the Building Geometry tab. In this Geometry tab, you are asked to give the project a name. So I'm going to name it Demo Manuscript. And for this example, we are going to use a 5-story building. You input the coordinates both for the X and Y direction in these two boxes. And once you are ready, you click Create Model. You can visualize in the bottom that the nodes of the model are successfully created, and then you can move ahead to the materials. In this section, you define the concrete and steel materials. For the concrete, you can define any material you want. For example, I'm going to define one here with a name C28, which is going to be a 28 megapascal reinforced concrete strength with a 420 megapascal steel. And for the detailing level, you have three options. DES, which corresponds to the special detailing of the ACI 318. DMO, that corresponds to the intermediate detailing, and pre-code, that is widely representative of buildings before the enactment of building codes. Once you define your model, you will see here that it was created, and after that you move ahead to the masonry material section, and for here you also define the name of the material. I'm going to call this masonry 1, or I'm going to call it FM4 for 4 megapascals. You can select the F-prime megapascals of the brick you plan to use, and you select if you want a vertical perforation or horizontal perforation. As you can see, it uses two equations for calculation of the elastic modulus of the based on FM, and I'm going to use here vertical perforation, and I'm going to add the materials. And once you add the materials, you can see it here. Then you go ahead to define the sections. For this example, I'm going to define a 55 by 55 section. It's a 5-story building, so it's reasonable. Then for the number of bars and of the section, you can go do that interactively here. As you can see, it asks you which materials you want. You may have more than one material, and you'll have to select accordingly the material here. Subsequently, you go ahead to define the number of bars at top, bottom, and the middle bars. For example, we are going to use here number 6 bars instead of number 8. And I think let's add 2 more bars at each side. So you can see here, this is the section we are going to work with. Let's add it at the top. And as you can see, it interactively updates the section. You can click add section, and you add the section. Now I'm going to define the beam. So for example, here I'm going to use let's say 35 by 50 beam. So I'm going to click here, 35 by 50. And the number of bars, I won't have any bars at the middle. And let's say we have 5 bars at top and bottom. And you can see how the plot updates the representation. You click add section, and here you can see you have both sections added. Then you move ahead to the element assignment. And in this tab, by default, it assigns the first section you created to the entire building. So since I'm satisfied with the columns, I'm going to leave them there, but you can edit it here. And I'm going to modify the beams to demonstrate how this works. Here I'm going to select beams, and I'm going to select the floors now. and you need to select which section do you want to assign. So I will assign the 35 by 50 beam. You can check here the details in case you don't have them in your head. And it asks you how do you want to assign the sections. You can do it by position, which for beams it means by spans, but you can also assign to all the beams in one floor the section you are selecting here. So that's what I'm going to do here. You click assign to all, and as you can see, the plot updates showing you exactly what you have assigned to your building. Then, as you can see, you go to the next tab, which is model visualization. One thing to keep in mind that the prior tab was only for defining what you wanted to assign. Here is where you actually create the properties in your OpenSys model. And for here, you need to select if you want diaphragms. You have the option for all floors, for custom selection for the floors where you want to assign the diaphragm, and you also have the option to assign none at all. I won't assign any diaphragm for this model, so I'm going to hit create elements. And now the elements are actually created. Then you go to the infill assignment, and here you are asked to select what is the width percentage ratio for the model. And as you can see, in the classical model for this for the walls as a strut, you select an equivalent percentage of the diagonal to be the width of the infill. So this is what the program is asking for. Here you have some estimations. For example, Priestley recommends 0.25 of the diagonal, which is the default here, but Bora recommends a third of the diagonal. So basically you have the option to select here whatever suits you the most. Here you need to pick which material is the masonry, and you need to select the thickness of the brick, and also you have to select the floors where you want to assign, and you can assign it by span or you can assign all span at once. So I'm going to do it here for simplicity to assign for all spans and for all floors the infills for a thickness of 10 centimeters. So you click assign infills and you can see here the updated visualization showing you where you actually assign your models. Then you need to go below and you have to apply the infills, and this actually creates the infills. Then you go ahead and in the load and mass assignments tab, you define the distributed loads. You can do it floor wise, which is every floor, every span, but you can also do it assigning the same load for all beams in the floors. And it has an option for the roof, meaning that if we select this option, this 70, let's say 60, is going to be the load for all beams in all floors except the roof. And if we put here 40, 40 is going to be the load on the roof. You click apply, the loads have been applied, and then you go to mass assignment. You can do it in a table like you have here, or you can do it in batch, let's say 8 tons per node. And once you click apply, you will see it here in this table. You need to apply the masses to actually apply them to the model. You have the option of nodal loads. We are not going to use that here. Then you move ahead and you have the option to save your model. I'm going to save it like demo manuscript, and it says that it is saved as a serialized file here. Then you can generate your script by clicking here, generate script. So you have the entire OpenSeesPy script for you to download and use later in your desired workflow if you need. You can proceed to the model analysis tab, where you can click compute model properties, and You here have the summary of the model properties of your model. Then you go ahead to the analysis tab where you can run the gravity analysis by clicking gravity, run gravity. Once you have run gravity, you go ahead and you can define your pushover analysis with a target drift ratio and your displacement increment. I'm going to set a target of 3% here. Let's and a 1 millimeter increment. And here you can see the control node, which by default it takes the node at the roof, and you run the pushover analysis. And as you can see here, it takes a while, and you have your pushover run. This actually, as you can see, it ran pretty fast. And you have here several results you can analyze. You can go ahead to the pushover results tab, and in the interactive drift analysis, you can actually visualize step by step how the building is responding, and you can go and look at the beams and column rotations that are displayed by the program. Here you have the rotation in radians, and you can compare these rotations with your any limit, for example, the FEMA limits as a reference. You can click any point and you can verify how the building is responding. And basically, this concludes. Oh, I forgot. After you have run the pushover results, I'm going to go back. You can actually save the results at the end, and it stores them in a serialized file. And this concludes our demonstration.